Hey everybody, this is Larry. This is day 29 of the September Legal Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. I have to, as you may be watching it in the last couple of weeks, I have to check out this apartment, Airbnb apartment, pretty soon. So that's a bit as easy. It's good. Let's get started. Split link this into parts is today's farm. Let's see. Okay. Hmm. So put it into an array of. Okay. So so you put in an array of linked lists. Wait, do we put in the value or because sometimes this output is a little confusing to look. Okay, k consecutive linked list parts. Okay. So is this just an array of linked lists? Okay, and optional. I do love monads, but that's besides the point. Okay. So then now we can just do something like okay. So for linked list, I always like to use a sentinel to begin. So let's just do that. Let's just say, yeah, okay. So let's just say answer is equal to, actually, I was going to write something like this, or times k, I guess. But I think this actually uses the same point of reference, so I don't think we can do that. So I think we can just do something like this. Just write it out. Okay, right. Let's make sure real quick about the syntax use. So let's run this to see. Okay, that's what I would expect. That's good. And then now it's not that bad. Now we just have to keep track of the current node. So then now current node is equal to head, and then count maybe current index. I don't know. So then now while current is not none, okay. So then now we put answer of current index. We add the next is equal to current, right? Yeah, I guess I have to do one more thing, which is okay. So this is the answer, but we have to want to also get the tail of stuff. So let's just do tail is equal to tails. Tails sub basically we just want something to look at the last element. So then in this case, then we have tails of the current index is equal to current index plus 1, or the current index. You can mod k somewhere, it doesn't really matter which way. So you have something like this, right? So then now we add this, and of course tails of current, okay, maybe we should have, then we don't have to do it multiple times. So then now we move the index, right? So it's equal to tails of current index dot next, or maybe just dot current, or just current in general, right? But basically, for linked list farm, I think maybe right now I'm not really explaining enough. But the idea is just to the idea is if you have trouble visualizing this, draw it out. Linked list farms are not difficult per se. That's why they teach it in intro, but they're not easy either. If you try to keep everything in your head, it's very easy to kind of be like, oh wow, this is a sea of stuff. I don't know what happened to my pointers. But if you just draw them out, have physical pointers to each node, then at some point this should be okay. So okay. So yeah, so basically we just have the tails for each linked list, and then we do this, right? And then now, I guess this isn't the answer. Let's call them heads, right? And then now we can return the answer, which is now for each head, we can node dot next for each for node in heads. Because the heads will contain the sentinel empty value, or not empty, but like useless value, right? So yeah, so that should be okay. Oh, we removed the answer somewhere. Where's my, where did I have it? Oh. More. There's at least one more. Okay, I forgot to probably increment somewhere. Or I forgot to move the loop, so that's why it's isn't gonna looping. I always forget to do this in while loops. I think in other languages I'm better about it, but because generally I don't use while loops, and that's it makes a lot of sense in most languages because for loops does a lot. But in this case, you can't really use a for loop, so I just get confused. Okay. Dong, dong, dong. Oh, I have to remove the nodes. Okay. So we are close-ish, maybe? Wait, expected answer. Maybe I misread this. I thought we do alternating ones. I think that's why I did it this way. So I actually misread the file. I'm sorry, friends. But I also didn't remove the pointers. Do we have to... Okay. I totally solved the wrong problem, so my bad. But now you know how... I mean, maybe minus the none, so we would have to do... we'll just have to keep track of the next node, right? Next node is equal to... What that next? My alarm clock, sorry. This is so I could wake up and not miss the bus later. But yeah. So I'm finishing solving this problem, and then we'll solve the actual problem. So this is a bonus problem for you. The next node is equal to current.next, and then here, yeah, that should be okay. And then we set this to none, right? So that we get rid of the old thingy. And this should be good. I mean, I know that this is the wrong answer, obviously, because I'm solving the wrong problem. But I mean, to be frank, this could easily be a Leetcode problem. Maybe it already is too, right? Just alternating. So I definitely misread this, or I don't know. I mean, this actually seems pretty obvious here. But I think I saw this example only, and then I made a mistake here. But that's fine. But yeah, like I said, so this is the solution for a different problem. Hope that is kind of cool and educational. But we can be, in this case though, it's actually less interesting, maybe, at least to me. Because then now we just have to keep track. I mean, just math and then that's it. So yeah. Okay, so this is the wrong answer solution. So yikes. But okay, let's start over. Okay, so what do we want to do now? What we want to do now is just do the math, right? So we have k. I mean, I think there's not going to be an easy way. I mean, if k was constant, you could do the fast, slow number of pointers thing with like if k was 3, then you can have 3 pointers, and one of them moves 3 steps, the second one moves 2 steps, and so forth. You can maybe still do that. Maybe that's okay. I don't know. But then there's also like off by, not off by 1, but like edge cases with an extra node and stuff like that. So so it's hard. So the first thing I would do then in this case is just count the number of nodes. I don't know if you could do it with one pass, but maybe you can. But I think I don't know. But I'm gonna be a little bit lazy and just count the nodes. So current is equal to head. While current is not none. Current dot next, and just pretty straightforward. We count the number of nodes, and then now we have, you know, div or div mod. I always forget which one. Okay, so then we have parts and leftover, right? And this is just divide and the mod. So then this is the part and then the leftover, which is what it sounds like, really. It's just divisible, right? And then now, per, this is not parts, sorry. K is parts. So then now you have per list or something like that. I don't know. How do you want to say per? And then here, now what do we want to do? We want the first one to, yeah, so now we have for I in range of K. We should go at index, but maybe I want to change it back to I because I think it doesn't really help that much. But I don't know, we'll play around that. Yeah, so if I is leftover, I think it has to be straightly less than. Then we do other stuff, but now we'll just write pass here so I don't forget. But otherwise is the we put per number into the list, into the answer. So okay, so let's just do answer is equal to we also set current is equal to head. Again, we use the variable name, which is probably a bad idea. But we should just probably put this into a helper function. It's probably the better idea versus whatever. But okay, let's actually do that then. Fine. Get ready. No. Okay, and then now, yeah, and then we just do Okay, so we want to put ends, we append current because that's the current node, and then now we move that up. I might be off by one here, so this is where printing stuff helps. So yeah. But then of course we have to set this up so that we have it for next time. Yeah, okay. Well, we have to do that after the leftover anyway. But yes, current is equal to next in the beginning, and then at the very end, the next is equal to current.next before we get rid of it. Okay, I think this is roughly right, maybe off by one, so that's kind of point. I wonder if I could print it out, but yeah. Okay, none type of, maybe I do have an off by one. Which one is it failing? Line 28. So this one, huh? Oh, whoops. This shouldn't be and. This should be per. Whoopsie daisies. Okay, so that's a real error, but that's good. It's a real typo. Okay, still an issue, but line 31. Oh, leftover. Did I miss this? Okay, let's see what happens without this for now. Huh. That should be. Well, okay. Current should not be n, but did I mess this up? Maybe I do have enough by one. Alright, so one thing I would do is just do one iteration first and then see what it's doing. Right, okay, so now the first iteration, it's already at 2. Oh, whoops. Maybe this. Because we set this in the beginning. Okay, fine. That's still a little bit awkward though. I don't think this is quite right. Okay, so let's. I think the reason why I am a little bit confused is usually I do set something like I do use Sentinel, so let's do that. Maybe that will help. Yeah, okay. Because then that will probably fix some off by ones, maybe. Yeah, I mean, so for the first loop, it looked okay. Let's actually bring back the. Hmm, this one also handles it, so maybe I am wrong on that one, though. Yeah, that's weird. So 310, so that means that there's one left over, so there should be one. Okay, we're good there. We're good there. So this may be a little bit um, misleading because it may just be that we don't set the none correctly. It might not be that we are looping too many or something like that. Um, hmm, but let's see, per. So we go 3 times. Eh. Oh, we should not do this because, we should, but I think um, this counts as one of the iterations, so that takes it away a little bit. But man, having more trouble with this one than I thought I would, to be frank. But okay, I think this only. We'll see if this is. Because my guess is that this only happens in the last iteration, but maybe I'm wrong. Because after it goes through the entire loops, maybe current should be none at the very end. Maybe that's why. Okay. But that's way more awkward. And of course, I mean, this is just wrong, right? So we don't handle the leftovers correctly. Or rather, I mean, because the way that we set it here, let me think about this for a second. Because the way that we set up here is because we always assume that there's one element. That's why this is a little bit off. But the two is a little bit interesting as well. I got the other ones right, so that's at least a good start. Let's also double check real quick. Okay, so everything is okay except for that one. So for the case where we have empty ones, why does this do 2 though? Well, just because this assumes that per is greater than 1, I guess. Yeah. Not greater than 0, I said 1, but yeah. Yeah, let me start this off first, but I don't know. Okay. Well, a lot of mistakes were made. So with per 0, we do this node. Oh, Huh. Let's see. Let's just debug it a little bit. Okay, so on the 0th iteration, it looks at it looks at 1, so that's good. And then on the first iteration, it looks at 2, which is expected. And the second iteration, it looks at 3, which is also expected. But then this one became wrong. Oh, um, hmm. I mean, I think I'm just being. I forgot one thing. I think that's why. I think we just have to keep track of the next thing, and that should be okay. And then I guess there's no need for this in that case, but yeah. Okay, so this is correct in at least the iterations. And then now we have to see why. Line 35. Sorry, friends. If current is none, which at this point it is, yes, that's fine. I mean, I could add more if statements. I'm just trying to think whether I want to. Okay, let's just try this for now. This is very yucky though. Okay. 31, okay. But this should not. Oh. So first, it's 5. Oh, we set the none incorrectly. So then the numbers after 5 is where did we set the none? Oh, because we moved it, I guess. Oh, and this. I guess so, but what? The current is none. I think maybe I just confused what I want to do. Because can't even spell else. Okay, so then next is equal to none, which is fine. I think we don't need any of this. I think this makes it a little bit confusing. We'll see what it does first. Okay. Huh. Oh, I see. Because if per is 0, we don't do anything other than leftover. So okay, I think this is way better than. Oh, sorry, alarm again. My second alarm, so I don't miss the bus again. I didn't expect this one to go that long, but yeah, okay. So then now, if per is 0, do we still need per 0? Maybe I don't need this anymore. I think I used it to hack what I was confused about with the 0. Okay. Now we have the same thing again. Why is it doing 2? Tell me why. So on this first iteration, oh, I know, because this assumes the at least one. That's why I did it that way. Okay. Okay, so if per is greater than 0, we do this. Otherwise, I think maybe we're okay. This is embarrassing now. um, because we. Hmm, let me think. I think the best way to do this now is to um, restart your mind sometimes. I definitely feel like I just messed up a lot. Um, yeah, and yeah, okay. Let me think about it for a second, right? So I have all these things of leftovers, but okay. Let's just actually do um, current part is equal to per plus leftover. So that's the number of things that we're doing. So then now we do current part. Yeah, if current part is greater than 0, we append current. Else, if it's just 0, then we append none. And then now for after current part, we do. And then now we can get rid of this, I think. Okay, and this. Oh, I went off by 1. Oh, I forget to set current is equal to next. Okay. I don't know what to tell your friends. Just having one of those days, clearly. Uh, hmm. Yeah, I need to get out of this thing to return the bike and stuff like that. But okay. Yeah, did I mess up on the math? Oh, I did mess up on the math. Okay, that part is fine then. I what this should be doing is current part equal per if I is the I don't know. Sorry, friends. I just woke up. That's my excuse, and I'm just really bad. It's actually not that bad. I don't know. I don't know why I'm doing so. It's one of those days. Uh, hmm. But I'm trying to think whether this is not true because this should be an invariant. So combine. Line 36. Do I still have this one? This is just a folder. This is so embarrassing, to be honest. Okay. So we're moving one more than we should. Again, because of this thing. So yeah, okay. Okay. Uh, I mean, I think hopefully this is useful in that when you see something, don't be afraid to kind of just restart, refresh. I mean, I know that the code is very similar, but yeah, let's test a couple more. Okay, so that looks good. So let's give it a submit, and even if it's AC, it's an AC of shame. But yeah, I sorry friends, that took too long. But like I said, definitely draw it out on paper and visualize things. As you can see, I had an off by 1, and I think I just kind of confused myself at a certain point with the pointers. But I don't get it. It's just for loops. So mistakes were made. I gotta, because this took way longer than I expected. I gotta run and pack and catch the bus and return my motorcycle and stuff like that. So I will see you later. Stay good, stay healthy. Yeah, couple of days left, so let's finish this. I'll see you later. To good mental health. Bye bye.